Hello and welcome to another language design video. My name is Robin Hansen. I'm the lead developer of the GREN programming language, or as exactly one person likes to call it, the GREN programming language. And today we're going to be talking about the future of operators in GREN. So in the previous video, I was talking about parametric modules, which will replace the current limited implementation of type classes in GREN. And at the end of that video, I teased that because operators in GREN require a type class like feature in the language, something's going to happen to operators as well. And that's what this video is about. Now, before we talk about uh, operators in general, we're going to have to look back and talk about why operators are the way they are today in GREN. And as with most other things in GREN, we have inherited our current implementation from Elm, which we started as a fork of. Um, and Elm has an interesting story when it comes to operators. So in Elm 0.18, I think, Elm actually had custom operators. So you could define your own operators. You can define their associativity and their precedence. Um, and people used that as a language feature. And in fact, several core packages, not core packages, but several very important packages made use of that feature. And for 0.19, the core team, me included, um, discussed what the future of operators in Elm would be. And we sort of landed on that operators aren't really a good feature. It's flexible. It allows you to write, to some extent, quite terse and quite beautiful code, if you will. But to someone who doesn't understand the operators, it just makes the code very cryptic. And most uses of operators are better served by functions. So we kind of like most of us felt that custom operators aren't really a good feature, especially in a language that wants to be readable and beginner friendly. Um, and so for Elm 0.19, that feature went away, or it didn't actually go away. The implementation was simply that people can't use custom operators anymore. You have to use the ones that are defined for you. This, along with the limitation that kernel code or um, calling JavaScript code directly from Elm was also limited. And I think those two things caused quite a backlash to some extent because there already were a bunch of packages that used custom operators that suddenly didn't really work anymore. Um, and I think perhaps even worse in retrospect was that even though the normal developer couldn't use custom operators anymore or direct JavaScript integration, uh, core packages, the official standard library, and or the official Elm packages could. And so you would see in the Elmlang parser package, there were still custom operators. And in the URL package, there were still custom operators. And I think that caused this perception that uh, the core team or the language creator didn't really trust other people with that feature. The feature still exists. There is syntax for it. It's just like if this isn't an Elm package, then you are not allowed to use this feature, and that rubbed people, I think, the wrong way. Uh, so that's really and we've inherited that implementation and that design decision from Elm, but now that we are looking into removing the type class feature with parametric, replacing it with parametric modules, we also need to find a better story for operators. Um, so with the basis on this history lesson, our takeaway from that is that, maybe we shouldn't have custom operators as the language feature, not for users in general, and especially not for me, language creator, or the core team for that matter. In practical concerns, what that means is, in practical terms, what that means is that we need to rewrite the parser API to avoid using custom operators, and we need to rewrite the URL APIs to remove those custom operators, and we also need to define a base set of supported operators. Um, and I think that's not necessarily a difficult thing. I think most people would be happy with operators that are well known in programming as well as not. So mathematical operators, Boolean operators, uh, and some function operators that we've kind of grown dependent on, like forward application and right function composition. Uh, but all other packages just remove them. And these operators would then be hard-coded. There wouldn't be syntax available to anyone for defining operators. The compiler would just know that, oh, it's one of these operators. That's the precedence rule. That is the associativity rule. And nothing else is valid. Now, while this just seems like, let's just, slim down operators, there is a case to be made for allowing people to override an operator implementation. So there are many languages that doesn't support custom operators, but they still allow you to kind of like redefine what an operator mean for a given type. So if someone were to create a big int type or a vector type or a ratio or whatever, it would make sense and it would be beneficial readability wise that people were to allow to define what plus means in the case of a ratio or a big integer or whatever. Similarly, it would be beneficial, I think, for people to define what equals equals means for their specific type. And so there definitely is a case there for being a little bit more flexible than only supporting a bunch of operators for concrete types. Question is how that work, right? So the concrete idea or the general idea that we're going with is that operators will become valid function names and that you can define an implementation for an operator using regular function syntax. So here's an example of that. If you were to define a big num type, and I chose big num instead of number just because it fit in this line, but you would do it like this, and it would look almost exactly like defining a function, except the operator is wrapped in parentheses. But then the question becomes, if you can define a plus for a module, and then the implementation of plus in another module, how do you decide which version of the operator you are referring to? And the thing is that currently the mathematical operators are imported using default imports, which is essentially just a set of imports that every single module has without you needing to define them. And so what we could do is that if you want to perform the plus operation on big nums, you would first have to unexpose the plus imported from the basics default import. And I, thought about this a bunch, and I couldn't really find a syntax that I actually enjoyed. Because if you're going to unexpose something, you're probably just waiting for the compiler to tell you when you have to unexpose something, unless you have enough experience to know from before. And I don't know. It feels because then suddenly you need to be aware of the default imports that exist, and I like that. I wrote it down a couple of times, and it just felt messy to me. So instead, I went for the other extreme, which is removing default imports in its entirety. Which means that if implemented, you will have to write every import statement that matter. And I guess the first impression most reasonable people would have is that isn't that just a lot of boilerplate, right? But we can mitigate that. We could make fully qualified module references um, implicitly imported. So saying that, like, so for instance, part of the default imports is the array module, the string module, the debug module. And instead of removing those for default import and require you to write the import statements, we could simply say that fully qualified module names don't need to be imported. They're already imported in a way, right? They're available. So you, even if you haven't written import array, you can still do things like array.map, and that will just work. And that would remove the need for writing import statements a lot. And I don't really think that's a problem, because it's not really ambiguous what you're trying to refer to. For tooling, you know, if you were to write your own parser, you might have to do a bit of extra work, but in Gren, the compiler will be available as a package. So I don't think a lot of people will do that. I think they will just call the GrenLang parser and get the information from there. The Gren parser, I mean. So implicit imports would reduce the amount of import statements you had to write. And I also think we can get by with some code generation. So for the next release of Gren, we're planning a command line command, I guess, which would generate modules for you. So you could write Gren generate module in the module name, and that would create a file at the correct location with the name you specify. And we could include a set of default imports there that you can edit to your heart's content afterwards. So by removing default imports, that might seem like a lot of work, but I think we can mitigate that so it isn't really a big hassle. And that gives us a natural way of letting the user select which operator they want to import into a module or not. Another thing that's important when allowing operators to be sort of like valid function names is that it's quite common that you want to use an operator on over multiple types within the same module. So say that you in general want to use the plus operator on ints, and so you import the int plus operator. But somewhere in the module you might want to do float maths and floats. But that wouldn't work because you're already using the unqualified operators for ints. So we need some way to be a little bit more flexible there. And the general idea there is that we'll allow operators to be qualified. So here's an example where you import the int module. The int module doesn't exist, but it would in this example, where you expose the plus operator. But then you also import float with an f alias, just for brevity. And so if you want to do float operations, you could do one f dot plus for float addition. And that would give you a little bit more flexibility. And of course, if you're primarily doing maths on floats, then you would just expose the plus function from the float module instead. And so this would be more like if you want this every once in a while, that's how you would do it. Yeah, so that's really the general idea, right? Define a minimal set of operators and hard code them into the language. Um, and to reiterate, those would most likely be the math operators, the function composition and application operators, as well as the Boolean operators, and then everything else would have to go, which to my recollection means that custom operators for URL parsing and custom operators for parsing in general would have to go away, right? And those would be the same rules for me, for the core team, for the community. That would be like same for everyone. And operators would really just be function names. So when you implement a function called plus, then if you have that specific implementation in scope, it, of course, the compiler would decide the precedence rules and the associativity rules, and they would, so plus will work the same in any context, but you get some flexibility in defining how it works within the context of your own types. And you can fully qualify operators, so you can do things like big num dot plus if you just wanted to use that inline implementation rarely. Um, and yeah, the benefits, it would work the same for them. It would be the same rules for everyone. It's compatible with parametric modules because parametric modules doesn't give you that plus works on any numberish thing, right? And it's a bit more flexible than what we have today. Currently, you have plus, it works on floats, it works on ints, but nothing else. Here, you get a bit more flexibility, allowing you to define math operators for your own custom numbers. Yeah, so that's it. If you have any questions about this feature, we have a language design channel on our Discord server, so you're free to ask questions there. And this is something we hope can be delivered with the rewrite of the parser that we're going to start on this fall, I believe. All right. Thank you for watching, and I'll see you in the next one.